Hello again. We're going to go through ACLs. I'm not going to really apply them too much. I'm just going to say how to do them. To apply them takes a lot more thought and a lot more time than we've really got at the moment. Our network is a standard network we've been playing with, and where we put our ACLs will have a big impact on what we want our network to do. It can mess up our routing protocols, it can do a whole bunch of things. So be careful with them, but understand them. So it's the start of access control. So in Cisco, I'll just pop onto router 3 to do this all on because it's a bit cleaner than the rest. Go into our CLI there. So with basic ACLs, there are two types that we're playing with, standard and extended. And within each of those, there is also numbered and named ACLs. So we'll start with standard and just go and create those, and then come back and create extended ACLs. Now generally with ACLs we follow the 3 P's. So per interface, per direction, and per protocol. The per protocol one I like to think of as a protocol suite, because the protocol of TCP, well not TCP but TCP/IP as a protocol suite, you can have in a single ACL UDP, IP, TCP, ICMP in a single ACL, and that's fine. But if you're using IPX, SPX or AppleTalk or something else like that, then that will be a particular another protocol suite that you're playing with. The per direction implies, if you go back into here, that either coming in, so from our LAN into our router, will come in to gigabit 00, get routed, and then go out. So the in is the direction, or out is the direction. Now we can go out of our gigabit 00 as well if we need an ACL which is coming into the router via the serials and then goes through the routing process and then out of our gigabit 00. So there's 2 directions per interface. So what we're saying with ACLs is you should create a single ACL for each interface, each direction, and for each protocol suite. Now we're only using TCP/IP, so that's a moot point. So if you want 2 ACLs on gigabit 00, one will go in and one will go out, and they should be 2 separate ACLs. You wouldn't apply the same ACL more than once across your router. Can be done, but generally good form to actually not. Okay, so let's look at standard ACLs. Now standard are generally only using IP. So let's go in and create them. So configure terminal. And we're going to create a numbered ACL to start. So type in access list, and then it's going to ask for a number. Now 1 to 99 is a standard ACL, and 100 to 199 is an extended ACL. Not strictly true. Standard ACLs also can run from 1300 to 1999. So that range there is not strictly true, but for our use, yep, we'll use it. And extended can run from an extended range of 2000 to 2699. But in our case, we're going to run it as access list number 1, and then we're going to start putting in our specific portions. We can put a remark in there if you want. Not a bad thing to do, but let's go in to start. So we're going to permit, and effectively we've only got a few things. The addresses that we want to match, any, which is every address on the planet,
or a specific host. So in our case, let's go for an address to match an address range. So let's go 192.168.20.0, and we now put the wildcard mask in. So if you remember, the wildcard is the complete inverse, in binary actually, of the subnet mask. So I want to match the first 3 octets of this. So I'm going to put in 0.0.0, and that is what will match because it's the inverse, and 255, I don't care what's at the end there. Now the cute thing with this wildcard mask in ACLs is we don't have to have all zeros and then all ones in that mask. We can actually have a mask of 192, which implies all zeros, 2 ones, and then all zeros again. So it does get a bit weird. Don't normally play with that because it's just going to make life a lot harder to read for you, but so be it, that's what we're doing. And if we look at it, that's it. So all we're doing is looking at the IP address range, and we're going to permit stuff with 192.168.20.0. And there it is, we've created an access list. Now, is that good, bad, or indifferent? Well, it's not too bad. We're only going to permit 192.168.20.0, the first 3 octets of that, and then we're actually going to deny everything else on the planet, because even though we haven't typed it in, we can actually type it in. Access list 1, deny, and any is the second line in our access list. But we don't actually have to type that in, because it's implied. As soon as you start creating an access list, the last command on any access list will be deny any in a standard ACL. So let's have a look at it. Show IP access list, and there it is. So our standard IP access list number 1 is our access list. The first line is to permit that value, and the second line is to deny everything else. That one is implied, we don't have to put that in. Now these values are nice, 10 and 20. What they mean is that if we want to permit something after we've permitted this one, so maybe permit 192.168.10.0 as an address range, and we want it before the deny any, then we would modify and we can inject a number 15 or a number 11 in between those two. We'll do those with named access lists actually, because you can inject the value into that. So there it is, one access list. Is it doing anything for us? Absolutely not. Doing nothing at all. We need to actually apply it to an interface. So put our configure terminal in there. To apply it to an interface, let's go onto the interface gigabit 00 and IP access group. What's the group? Well, it's number 1 is the name. We didn't give it a word, so it's not a named access list, so we're putting in a number between 1 and 199, which implies standard or extended. And then we are saying in or out. And in our case, we want to go out. So, show running config. There's our access list. If we go onto our interface gigabit 00, we've applied the access list as a standard ACL, and we sent it out. So, will things accept that? Let's check it out. I want to ping 10.0.0.1. And it's killed us. Is it? Let's check it out. Timed out. Let's have a look at
simulation mode, and we'll go from this PC to that router. Slightly different. Capture forward. And what it's done is stopped our ACL from going through. So it's a bad ACL. What we've done is that address range is the source. So I've done it actually intentionally, put a bad one in there. The source address range is that, and we've put this one as out, so that if we go back to the ICMP there, and we'll capture forward, go there, and it comes back, if we actually have a look at the inbound PDU, the source is now 10006. The destination is that. So standard ACLs have quite a degree of failing in them, because they only look at the source of your packet, and everything starts to get a bit messy. So let's fix this. Interface gigabit 00 IP, oops, let's get rid of the out one, so no IP access group 1 out. And actually want to do, and I'll stop my typing because as you've probably seen I'm not a good one. We want to say IP access group in. Let's have a look and see if that works. So we'll go into simulation mode again, and we'll do that one again. Whoops. Now again, this is a fairly moot point, because we're permitting IPs from this internal network to come through. If we had a different IP scheme down here, so 172.20.00/16 network address, the IP address of that interface will be different. We'd have to have another router and just send it to that address and send different traffic through. So standard ACLs should be as close to the destination as possible. But again, I'm not going to go through the whole process of actually doing that because it'll just take too long. So what we've done is actually put it on the inbound interface. Standard ACL will read the inbound traffic, so the source address, and run from that. So show IP access lists, and we're going to match the source, that is 192.168.20. And the implied, which we did actually add in, is deny everything else. So in this network it's a bit messy to actually do that. To get rid of our access list off an interface, that's it there, it won't be applied, so that's good. So conf t there, interface gigabit 00, and we'll take that one off and just leave that ACL floating in the breeze. It's not applied to anything, so it's just sitting there not doing anything and just taking up a bit of RAM. Okay, so we've created a numbered ACL. There it is. We just typed an access list, gave it a number, said permit or deny, and whatever we're permitting, we need to match this information. We could have used host, or we could have used any. That's the options available for us. And we've used a number to say whether it's actually as standard or extended ACL. In this case, the number between 1 and 99 is a standard. So let's go and now create a named ACL, which is done slightly differently, and in my view, a better way of actually creating an ACL. So conft configure terminal. If we now type in IP access list, and we'll put a question mark in there, it'll ask us, do we want an extended access list or a standard access list? In this case I want standard, and we give it a name. You can actually go into there, put the number to inject different things, so I'll come back to that. But for now we're going to do names, and our name should be descriptive, so mine's not going to be particularly descriptive. I'm just saying standard ACL, and we hit enter. So named ACL is the NACL, and now we just go straight in and we can change our sequence numbers. That's the numbers I talked about before. We'll come back to that. We can put a permit, remark, deny, default, tend not to use. So let's just go in and do the same kind of command that we did before. So we're going to permit, so that network number, we're not going to put any, we're not going to put a host, so 192.168.20.0, and the wildcard that we're playing with is 255. Done. So let's show IP access lists, and now we've got two access lists in our system, a standard IP access list number 1 and a standard IP access list, and it's given a name. This is now a named one called STD-ACL, and these are both the same. This one says to permit 192.168.20, and we're going to match the first 3 octets. There's an implied deny any after this as well. In here we've actually just written it. Now the cute thing with this show IP access list that we've got there, it's giving us a bit of statistics, how many matches we're actually getting. So when we failed that access list there, 5 matches actually denied any. This one won't give us that option. So let's now apply this access list to our interface. So interface gigabit 00. Again, I'm applying it as close as possible to the source. Standard ones you should apply as far away from the source as possible, as close to the destination as possible within your range. So it kind of implies right out here, depending on where you want to go. So IP access group. Now here it wants the word that we want, and it's standard ACL. So STD-ACL, and in is what we want. So we've done 2 things there. We've created 2 different types of access lists. Well, actually not 2 different types. One standard numbered ACL and one standard named ACL. We initially applied the standard numbered ACL, so number 1, to the interface. We did it incorrectly to show that the IP address that's in the ACL is the source. The numbered one is still the source, but we now have a number to play with. And we've applied this named ACL to our interface in their IP access group, standard-ACL in, and it'll do exactly the same as the numbered one did, and everything is sweet with the world. So, one more thing to play with in this. I did talk about putting in a new line. So, do show IP access lists. So I said before, I'd like to actually permit a different address to go in between the 10 and 20. So how can we do that? Well, we go into a named ACL, so IP access list standard and 1. Now even though I'm using the named option, I'm naming it number 1. And if I put a question mark in there, then I can play with my sequence numbers. So if I put a sequence number of 15 in there, then I can start adding my commands. So let's permit sorry, let's permit host, just so that we know how to do it, and we put the actual host address, so 192.168.20.10. So an absolute address. Now this is going to mean nothing because we've already permitted the first one, but let's just go through the process and have a look at what we've done. So show IP access lists, and there we can see that we've injected this line into that numbered ACL, and we can do the same with this, the named one as well if we had more than one entry in there. Okay, so last little bit to go through. That command will be done first. If there's a match for that, then the packet will disappear and go and do what it needs to do. If there isn't, then the next line will be done. Now between these two, we'll never get to this line if this one's already permitted, because that's a bit daft. But yeah, in ACL method, that's the process. If we don't get a match for that, then we go down and we hit the third line, which is deny everything, which will be matching everything across the board. So we can use these ACLs to provide security. We can also use them to actually debug different things. We're going to actually use them for network address translation later on. So they are quite handy little beasts. But that is standard ACLs in a nutshell. All good. Done. Thank you very much.